Alright guys, in today's video we're working on this SeeSii portable spot welding machine that I have, and it has just decided to give up the ghost and quit working. Pull these cables out of here for a second, but it won't power up anymore. And so what I think has happened is that the internal rechargeable batteries have probably dropped below the minimum voltage for it to take a charge, because it won't charge them up. It's a metal case on this model. There's 4 Phillips screws on the bottom here and 4 Phillips screws on the top. We're going to remove those, and we're going to see if we can get access inside to see if we can repair this. So I'm hoping it's going to be just the batteries, but if not, we'll take a look at the board, see if we can figure out what's wrong with it. It's very good at what it's supposed to do, but it doesn't have a very long shelf life when you're not using it, apparently. I did a video on repairing some battery packs and an appliance on this one at one point, but I haven't done any videos since with it, but I've used it a lot. But it has been sitting probably for the last 5 months, and I'm thinking that the problem is that the batteries have just discharged down. So today we're going to see if that is the case, and I'm going to take you guys along with me while we check it out. If the batteries are fully discharged, then it wouldn't be safe to try and charge them separately, so we'll just put in new pouch type batteries. This takes a pouch type battery. You'll see it as soon as we get it open, and those are still available. Come on. One more. Okay, don't want to lose these screws. All right, so you'll see, like, falling out the back here, there's going to be a couple of spacers. So there's the battery pack. There's 2 of these. This blue PVC is like a shrink wrap holding the 2 packs together. These are just some kind of safety device to keep it from sliding around, so we'll take those out. And then it's easiest to bring it out through the front where the buttons are. You can see that if we zoom in here, you can see the little screen has got enough clearance to come through. The danger on this model here is to keep it upside down like this with the buttons on the bottom, because when you see at the back, you're going to see that the plus and minus terminals of the battery are very close to touching and shorting out on this metal case. It's just a typical Chinesium quality, but I'm just pushing with my finger from the back, pushing the battery pack through until we can get it through enough to grasp the board and start pulling it through the rest of the way. And you can see at some point in the past, I put a couple of insulating strips over those 2 battery terminals I was telling you about. Now it's kind of hard to get out here. It might have gotten a little puffy. Yeah, these batteries might have gone puffy on us. But this is the basic setup. So you got 2 pouch batteries. The type of battery is right here. If we zoom in, it's an 1170-80 type battery, which means that it's 11 millimeters high, 70 millimeters wide, and 80 millimeters long. So 80 in the up-down direction, 70 in the left-right direction. And then this other information over here on the right, I believe that's going to be the amp hours. So this is, each one of these is 5350 milliamp hours. There's 2 of them stacked together. They're wired in parallel. Just trying to see, yep, there it is, B plus and B minus. So minus and plus. So if we grab our voltmeter, you can kind of see if these guys are drained out. When they're in parallel like this, the voltage will stay the same. It's just a combination of the capacity when they're wired like this. So minus to positive, nothing. Not getting any reading at all. So yep, these batteries are dead. I wouldn't even bother trying to take them off and recharge them separately. What we will do, we'll take these 2 little pieces of insulation I had on here off. This type of battery has just got like a kind of like a flat tin. You can see coming out here, terminal, right? And it just goes through the circuit board. So what we'll do is we'll straighten these out. They bend it down a little bit from the factory to try and avoid it shorting out. I don't know why they don't just, cut these flush. And then to get this out, what we'll use is we'll desolder this with some chip quick, which is low melt solder. It's probably the easiest way to get something apart like this. But given the battery state, I think that's the case. What I'll also do here is I'll grab a pair of scissors, since we know that we're going to be ditching these batteries, and we'll just try to get an idea for the manufacturer. Now this I want to be super careful on that I don't short anything to the terminals, and also that I do not pierce the battery. So I went kind of close on that one. Just going to kind of go super slow here so we don't do that, just so we can eventually get over here and see what we got going on here. Just want to be careful that you don't pierce it. So these are just creases, not piercings. And so here we can see it's a model 117080, like I said, 5300 milliamp hours. Looks like the manufacturer is a company called Sheeta. 3.7 volts. 19.61 maybe watt hours. So what we'll do is we'll source a couple of these to replace these ones that have gotten all big and puffy. I'm pretty sure they're puffy, easy to check. So the spec says they're supposed to be 11 millimeters high. We'll grab our digital caliper, zero it out, and we'll kind of peel one off here. Let's see, what do we got? No, they're not really puffy. Just 11.33. So if I can get this where you can read it. There you go. So they're not puffy. They just are. Just got a lot of, I guess, slack in the packaging. The foil, but they're still fully discharged, and so it's not safe to try and recover them. So we'll solder these out. We'll get a couple of new ones sourced, and we'll put 2 new ones in here. So when you're doing something like this, it's extremely important, because this is all kind of sketchy to begin with right out of the Chinese factory. It's extremely important that the replacements be exactly the same. So only an 117080 type battery, nothing else. Exact voltage. And you got to try and get as exact to the milliamp hours as you can. So 5300 would be ideal. 5350 would be fine. I wouldn't go any higher than that. You want to get them bought in a pair so they're matched. Just trying to see here. It looks like, yeah, there's just some glue holding these two guys together. Piece of sticky tape, actually. So yeah, we'll be able to separate that when we need to. And you get them matched together, and then you want to make sure that they're both close to the same charge before you make contact when you're trying to wire something in parallel like this. I got to look at the spec, but I think it's like 0.3 or 0.4 volts. As long as they're within that, you can touch the leads together and solder them on. If not, we'll have to separately charge the new ones up to get them closer together so we can do this. And then once we do that, the onboard circuitry should be happy and charge it the rest of the way. So let me show you how we desolder these. All right, guys, let's go ahead and get this old battery pack off of here. On the other side, let's bring it out here for a second, you've got a display, and you can optionally remove this guy. It's just a push-in connector, but rather than disturbing it, I think we're just going to try to leave it alone. I put a small paper towel here just to give it a little bit of cushion. See if I can zoom you guys in. Now these gold traces are really thick for the amperage that they have to carry, so it's going to act like a heat sink. So we're going to have to up the voltage, I'm sure. But let's see if we can start off with around 425. So I'm going to put some flux on here to help us out with this. I don't know if this is leaded or not leaded solder. It probably is not leaded. And the only way we're going to get this off with something like this is to contaminate this solder with a material with a lower melting point. So I'm going to be using a product called Chip Quick. And we're just going to try to heat everything up enough to kind of melt in the chip quick with the existing solder. So I'm going to set off camera here rather. I'm going to set us up for 425 degrees Fahrenheit, or excuse me, Celsius. And then we're going to get started and see if we can get this guy off. Put our exhaust on. Let's get started. It's going to be a lot of heat to melt this guy, but we're starting to get it. And then what we're going to do is we're just going to put the lower melting temperature alloy in here and contaminate all of this. Do the same thing on the other side. Good. Okay, then we're going to have to flip it around, or move it around rather, and do it on this side. Can use up every little bit of our low melt solder. All right, I think we're good on that side. And now we'll come and do the back side of this terminal. All right. And if we're going to have some luck here, be able to get this to come out of the board. I can feel it moving. We got some spot that is not adequately contaminated yet that's holding. I can't find out where it is though. This is a really, really large soldering point. There it is. I can feel it right there. Feel something anyway. All right, so this side we're getting to let go. We're not having luck with this side. Not sure why. We're caught on something over here. Let's kind of look at the other side of the board. See if we can work it from this side as well. Yeah, there might be some more solder on this side that we can't see. Let's see if we can get some more of this low melt in there. Alright, well, I don't know why that side is giving us so much difficulty compared to the other side coming off the way we would expect. But I'm going to go ahead and just pull the terminal off the other side, get it out of the way. Yeah, it's really awkward to do this with having to keep the camera where you guys can see. That one came off just fine. Just going to bend it away from the board. And we're going to try to figure out what's going on with the other side. I can't get it to let go on this attempt. I'm going to have to go in and wick off a lot of this solder material so we can get a better view at what it's hung up on. There may be a bend or a fold in one of these terminals that is mechanically catching on the slot in the board. Just first going to get it really heated up. Try to get some force on it. Try to overcome any mechanical interference. Oh, she's stuck on there. All right, let me get some wick, and we'll try to take some of this material off. I'm not sure what's going on with this. Alright, finally feels a little smooth along the edge of this slot now, so maybe we just had some solder that wasn't mixing with our low melt. So we'll try to get this guy off again. Apply some tension. Get it remelted. See if we get any progress. All right, still fighting us. Feel something right there. You guys can see it. Just kind of pushed it out of the way right there. All right, taking too long on this. What we're going to do is we're going to cut that battery tab, and then we'll try to pull it through in the other direction. So just very carefully where we don't bridge the contact points. Let's see if I can cut this. Being extra careful to not have the tool get anywhere near the circuit board. And I'm using my other finger to make sure that the terminal that we already freed up doesn't make contact either. Alright, so set this battery aside. Let's try to figure out what's going on with this piece. Try to straighten it up. Get any of the bends out of it. And then see if we can just pull it straight through. Sorry about that, guys. I was not anticipating any problem with this. Should have just went like the one that we did on the other side. Yeah, so we got one side freed up. I really feel like it's just at some point we're not getting all of the other solder mixed in with our low melt. That's got to be what we're fighting here, just because of the shape of this. You can see it's moving now. All right, finally. Jeez. All right, what we're going to do now is we're going to go clean up all this debris. Make sure we didn't do any bridges on these MOSFETs over here, or take some braid wick and get all this material cleaned off so we can get ready to put the new battery on. I'm going to kind of work at the side here so you guys can see above. It's going to make it take longer for me, but I've already done the other one. It's basically we're just trying to wick out any of this remaining low melt solder so that it doesn't contaminate the new joint. And then we'll come in here with some isopropyl alcohol and we'll clean this up. And then I'll show you the next steps. Let me have a look at this. Yep, that's cleaning up really nice. It's a little bit stuck in the corner here. I'll fish that out and then we'll clean this up. Just going to get all this flux residue off of here on the edge of the board as well. And then we'll take another look at it under the magnifying glass and we'll see if it looks okay. Alright, so what are we going to replace this with? So this was a SeeSii brand, 19.61 watt hours. The size was 1170/80, 5300 milliamp hours, 3.7 volts. And so I managed to find exactly what we needed. SeeSii, 19.61 watt hours, 5300 milliamp hours, 3.7 volts, 1170/80. So this is the identical battery. And I'll put links in the description where you can get this. So let's take a look at what we've got voltage-wise on these replacements. So they ship them with some Capcom tape covering them up here for safety reasons. Let's see, it's positive on the left and negative on the right, I believe. And if we move the camera back, we've got 3.86, 3.87 volts on one. And then on the other one, pull that off. That off. Let's see what we got on this guy. This guy we've got 3.80, 3.79. So those are close enough together that I'm not concerned with hooking them up. If we had more of a disparity, I'd be more inclined to want to charge this first before having them make contact with each other. Trying to see what they got going on here. It's like a ridged fold that the original ones didn't have. So I guess maybe what we'll do is we'll just kind of make it go up like that. So it seems like the replacements, they've stamped in, if we zoom in, they've kind of stamped in this piece of copper here. Not sure why. But that kind of interferes with our application because we need to have it be able to go through the board. I'm hoping we can do it like that. And who knows, maybe I didn't notice this. Maybe this is why we were having some problems desoldering the other original ones. Can't tell. But I don't like that, and I think that's going to make it more difficult. I'm just trying to see. I need to think about this, whether I want to try to pry this out and remove this piece of copper, and whether that's going to be enough to go through the board if I do. So give me a moment to think about where we want to, whether we want to leave this the way it is or we want to remove this. All right, guys, so if we zoom in, it does appear that the original batteries had this kind of two-piece crimping as well. It just wasn't copper, so we didn't catch it. And it was a lot more flush, as you can see. So what I've elected to do is I've gone in at the crimp point, and I've taken a pair of pliers, very carefully, put your finger here so you don't get a bridge situation, and we've crimped both of these down so they shouldn't be a problem. And so what we're going to do is we're going to go ahead and let this guy be our bottom one, this guy be our top one. I'm just going to do a test fitment here to see if we're going to have the ability to go through the slots on the board, and it looks like we'll be fine on this side. And we'll be fine on this side. All right, so with that, I'm going to go ahead and take some double stick tape, kind of replicate the original setup using this material instead of what they originally used. And then we're going to get these guys where we want them. And that'll hold them together. And then what we'll do is we'll also put the heat shrink around them just the way the factory did as we solder them in. All right, what's next? Well, next thing we're going to do, take our old one, even though there's no voltage. We'll use these pieces of Calcon tape to kind of seal this guy off, just in case. These kind of batteries have a nasty habit of starting fires, and we don't want to have that happen. And this can go off to your local county recycling center. All right, let's bring the board over here and do a couple more tests before we solder in the replacement battery. All right, so let's zoom in on these MOSFETs. And let me see if I can catch the right angle of light. There we go. So this here is the manufacturer symbol. It's like a I with a D shape around it. And then on top is the number here. This is 4N04R8. So that's the type of MOSFET that's on here. And there's 3 on this side, and then if you flip the board around, there's 3 more on this side. And so what we want to do with these, while we got everything disconnected here battery-wise, is we pull the camera back out. We want to see if we can measure that they're all okay, right? And so here's the data sheet for this. So that symbol is for the Infineon Semiconductor Corporation, and this is an Optimos T2 power transistor, right? So there's the marking 4N04R8, and they tell you that the package is an HPSOF. That's a heatsink plastic small outline flat lead. That's what that stands for. So that's the type of packaging. And what they're telling you here is you've got 8 pins, and then you've got this tab with like 3 notches. And what they're telling you is what's relevant is 1, 8, and the tab. And so pin 1 is the gate, 2 to 8 are the source, and the tab is the drain. And if you see right here, there's a symbol for a diode. And so what we're going to do is we're going to do a diode test between the source and the drain. Right? And so that's going to give us an idea about whether this is a good MOSFET or not. So let's go ahead and test all 6 of these. All right, so somewhere on your meter you're going to have a diode symbol, and that's going to tell you that you have a diode test. Now, on this particular one, we've got to cycle through the functions on that multi-function selection until we get a diode symbol up at the top, and now we know we're in a diode test. And so now if we take our leads, and then remember these 3 pins from the data sheet are the tab, right? That's the 3 tab. Then you've got your gate, and then pins 2 through 8. So we can grab any one of these and any of these tabs here, and we should have nothing in the negative to positive direction. And then if we flip the leads, we should get a voltage drop. And if we slide over to the meter, we do. And so that tells us this is a good MOSFET. And so we can go all up and down all of these. So this one's a good one, as long as it has no conductivity in the other direction. And it doesn't. And then this one. Now, is this the only test you can do? No, you can also do a resistance test, but we're just going to go with this test because we don't expect anything to be damaged. We're just trying to verify that. Now, when you get on this side, because of this riser spacer here for the display, you're going to have some obstruction, right? So you'll be able to get this guy. When you go do this guy, you'll have to grab, if we zoom in here, you have to grab that very corner tab right there to make contact with, and then go over here and complete the test. So I'm going to go test these 3 as well. We'll make sure they're good, and then we'll resume our battery installation. All right, so we remember our original battery had this kind of blue heat shrink on it, and then it also had this little spacer. We're going to want to salvage this little spacer if we can. That's some really, really strong adhesive on that. I'm going to have to take that really slow so it doesn't tear, so I'll get that later. But you're going to want to salvage that, take your time getting it off. And so now what we want to do is replicate this piece. So we're going to use some approximately same color and size. Figure that it's going to be about to there. All right, so we're going to go ahead and cut this. I'll give you the dimensions of this down in the video description to fit this particular battery. Go ahead and slide this on, and then let's go get a heat gun, and we'll shrink it around it. All right, that'll keep our batteries nice and still. Let's go ahead and solder them in. All right, for this particular board, now that we've verified everything, if we zoom in a little bit, we can see that this one has battery plus and battery minus silk screened on the left and on the right. And so I actually had this, had to twist this the other way. You got to make sure that you've got it set up so that you're running plus on the left and minus on the right here, and then you're going to solder, not from the side with the display, but we're going to solder it on the opposite side, right? So we're going to need to grab a pair of pliers because we're going to need to manipulate this guy, and the kind of pliers I'm using for this are flat jaws with no teeth. No teeth. Right, so that'll allow us to grab and manipulate this. You got to be super careful because you do not want to bridge it to the other side. But you got to get them straight so that you can run them in so we can do the soldering. Well, there you go. We already know we fixed it. I don't know how to get him turned off right now, but let's go ahead and keep working on getting this second terminal in there. So I'm not happy with this guy sticking up like that. So what we're going to do on this guy is we're going to pull him back for a second. And then we're going to take our pliers and we're going to kind of bend this guy down. And then we're going to bend the copper up. And then on our negative, try to get these guys to stay together more. All right, so we already know we fixed it. Now let's just finish the repair. Get this guy soldered in and we'll be good to go, where we can pick up and do our spot welding again. What's happening here, guys, is the second battery terminal keeps getting hung up for me on the negative side. So I got both the positive ones in. And I got the first one in. There we go. Finally got them both in. All right, let's see if we got enough sticking through here. So I'm good on positive. I'm not happy with negative still. Still not enough. There we go. There we go. A little bit more. Gone as far as I can on the positive side because of that kind of crimp. If you zoom in here, right, we're going to get some mechanical interference right down here from these two bends. There's nothing else we can do about it. What I might have to do is just solder in the positive first, because that's the one that's working out for us, and then come back and do the negative second. Let's go ahead and get this going on the bench. All right, guys, we finally got this manipulated around to where I think it's where it needs to be. As you can see, there's a seam here. If we look on this side, right, here's the positive terminal for, I'll call it battery A, and then here's the terminal for battery B, and then similarly for negative, we can see the seam on both of the terminals now. Maybe if I hold it up the camera, you can see, right, there are different lengths. And so now what we got to decide is, well, we're going to have to trim this off for safety reasons so it doesn't make contact with the metal housing. We can either tack this on with a few solder pieces and then cut it, or we can remove the board after all this fighting and cut it that way. And I'm actually going to elect to do that. I'm going to get a Sharpie and mark where I want to cut this, and then I'm going to pull the board off because it'll be safer that way. If we don't, accidentally get to the end here and we slip, and we don't want to create a bridge and bridge these two positive and negative terminals together with the tool that we're using to cut the tabs. So we're going to pull this out and cut these down to size. All right, so we pulled our battery out. You can see if you zoom in a little bit, we put a couple of Sharpie marks. This is what we want to cut off and trim to get it to where we want it. And I'm just going to, always thinking about safety here, we're going to keep the negative terminal over. We're going to see if we can use these same tools that we cut the terminal that was stuck on the original battery. See if it'll cut through these copper tabs. If not, I'll have to find a different tool, or I'll have to do them one at a time, perhaps. And that's really, that copper is really not cutting well with this tool. Let me try and get a pair of wire cutters and see if we can get it off with that. Yep, that's fine. We actually, of all things, it's going to get cut with a pair of super sharp scissors. I would have expected it to have come off with one of our wire cutting tools, but wasn't in the cards. You can see why we have this paper towel here, right? Because it's very easy for this type of tool to bridge the terminals together, and that would not be a good day. All right, go ahead and reflatten these, and then we'll just do the same thing on the other side, and I'll bring you guys back when we're ready to solder it in. All right. This took a long while to get it back in here and coax it around. We're finally ready. Again, we're going to have to use higher heat than usual because of the heat sink effect of the way this board's designed to handle all the current that it has to handle. going to do the negative side first, and I'm going to be using leaded solder. I'll try to get in here where you guys can see, hopefully. Just got to get this guy heated up enough where we can do what we need to do. Yeah, see, that heat is just being wicked off. We're going to go ahead and go up to 450 Celsius. Just really got to overcome this current sinking effect. We're not going to be able to get this the way I would like, so we're just going to kind of tack it in. Not my best soldering job here, just because of how much heat we're having to pump in. I'm also worried about having to pump in this much heat just because of the battery. Some sense the flux might be helping us. Maybe I should try some more of that on the negative side. Initially went pretty good. Let's try that. You can never have too much flux. Okay, let's see if we can use the iron to bend that a little bit so I can see what I'm doing. Now I'm not going to try to solder on the other side. Just going to get whatever we can get to wick in from this side, and that's going to be it. I just need this tool to be functional. And that's it. Yeah, it's like really soaking up all of the heat from the soldering gun. Cannot get the solder to stay melted. That sucks. Just wicks off just as fast as we can do it, but I think we've got it in here good enough. Alright, I'm going to go ahead and try to clean this up a little bit and finish the other side of the negative, and we should be good to test this guy out. Alright, so we carefully removed our little spacer pad from the old shrink wrap, put it down here at the bottom on the solder side at the bottom, and then if you zoom in here you can see we did clean this up as best we could. I'm satisfied that it's going to be okay for the purposes that we need it for. I'm going to put these two little strips that I personally added just as another insulation insurance item so this guy doesn't touch the metal housing. You can also use hot glue, but I would recommend you do something. Alright, so now we're going to put it back together. So if you got any lint or dust on the display, Catch it now, or it'll annoy you all the time when you see it in there. Go this guy in. Looks like our new battery is just slightly thicker. Rats. So, given that problem, I'm going to remove this little spacer. And line up our board. Into the little slots that it goes in. Making sure that we definitely have no chance of that hitting. And you know what I'm going to do? I'd prefer this little spacer actually just sit right there. There's another piece of insurance for that problem. All right. And then we're going to take these two little pins, slide them in the back piece, and then we'll go ahead and put the back on first. And then what we'll do after we get this reassembled, we'll hook it up on the charger and make sure that it's able to charge the battery. The last time it popped on, I think it said it's 60-something% remaining, which makes sense. Let's see if we can have it charge up to 100 the way it's supposed to. Last one on the back. All right, and then the front ones, you want to line up the ports properly. One more. All right, she's all reassembled. This is how we started this. And now if we just tap the red button once, she comes on, 67%. So let's get out a charger and see if we can get that up to 100. All right, we've had this guy charging up for about 2 hours. And it's went up about 20%. And you can see it's on one of these kind of old school iPhone type chargers, right? And so that's on purpose. That's very conservative. You can see it flash up here that the input charge current's about 0.5 amp. You know, these batteries, we don't know anything about them, right? So we're just kind of going real conservative. This device could take up to a 2 amp charge according to the manual that came with it, but we're going to go small here. Just to see how these batteries are doing. So we're just going to let it creep up to 100. And again, don't leave it unattended, right? You want to keep this in sight just in case something does go awry. We'll come back to it and see where we're at when we get to 100 and how long it took. All right, guys, it took a little over 6 hours, but you can see we've fully charged up our new batteries, so everything's working great. And we used one of these little 0.5 amp Apple iPhone chargers to do that. So it didn't overheat, and obviously it didn't catch on fire or anything, so I think we're safe, good repair. The only thing we're going to do now to make sure that we're absolutely good to go is we're going to give it a quick test. So we're going to go ahead and plug our leads in. And then we're going to see if we're still able to actuate this guy. We zoom in here. Great. Whoops. All right, so she's working. She's fully repaired. And at this point, the video is done. If you guys have comments or questions about what we did to do this repair, go ahead and leave it below and I'll try to help. If you've got a piece of feedback on something you've done similarly, I'd love to hear about it below. Go ahead and leave that too. If you found this useful and you got your portable spot welder working, appreciate you paying it forward and hit that like button. And as always, thanks for watching.